So part two, number 6 says the mean score of all GRE scores is 150.8 with a standard deviation of 8.8. The scores on the quantitative portion of the GRE are approximately normally distributed with the mean of 150.8. And a standard deviation of 8.8.
Deviation 8.8.
Alright. B, what proportion of the people who take the quantitative portion of the GRE will score above 165? What would we do the equation wouldn't we have to find the z-score and then do it from there?
Yeah, I think so. I didn't write down how I did it on mine. Let's check.
Are you doing B?
Yeah.
6B? So you have to find the z-score first.
Uh-huh.
So did you get 1.61 for the z-score?
I did.
I've done it.
It's frozen.
I put, I got the z-score and just put it in the app thing.
Okay, yeah, in the little
applet.
Mm-hmm.
So did you get 0?
I think everything froze on my end for a second. Okay. I got 0.0537 when I just put it in now. But on my thing I have 0.0533. I don't know why there's a difference there. But
there we go. Okay. Let's see what I did. So for the z-score, I got 1.61.
yeah.
Is that what you got?
That's what I have.
Okay, so then it would be what portion of the people who take the quantitative portion of the GRE will score above 165? Then would that be 0.0537?
Yeah, because that's your area that they give you, which is like the percent.
Yeah. So then it would either be 0.0537 or 5.37%. Cool. Let's see if that's what the percentage. Yeah, pretty much. It's a little different there.
I don't know how I did it. That's what I just got now. But when I did it on earlier it says 0.0533.
Yeah, me too.
So
That's
I'm
weird.
trying to wonder what I did. um,
Huh, that's weird.
yeah, I don't know why it's different.
Oh,
Did you
oh,
figure it
maybe
out?
it's because I put 1.613. Maybe see that changes it. Oh, then 63636.
I know I didn't put the
Yeah.
whole thing in there, so maybe.
I think if you put 1.614, it then gets 0.0533.
Okay, maybe that's what
So
I
if you were
did.
to just round it to the third decimal place, then it gets to
Oh,
be 0.0533.
okay.
So cool. Good to know. Awesome. Did you guys get that? Uh-oh. Where did Mindy go? Elena?
Yeah.
Okay. Cool. Alright, so should we look at...
So I can connect again.
It seems like it's working now, Mindy, by the way. It was kind of going out before.
Yes, I can hear you. You're not all truncated in your speech there. Yay! Maybe I can actually communicate. Where are you guys at?
We're at C.
Okay.
Because I think you were saying that you got B earlier, right?
Well, I got 0.0537 as when you put in the applet or whatever. Is that right?
Yeah.
Okay.
Yeah.
Yay, I got something right. Okay. So you're
And
on.
then, so C, we're on C, yeah.
Okay.
So if a
So,
student scored the 10th percentile, what would their corresponding score be?
1.282.
So would we just have to move the little red things?
Is that how you do it?
I think you just, if you put it in area, that's your percentile, so you just put 0.1 for 10%,
Okay.
and then it'll give you your z-score on the bottom.
Okay, cool. So would we have to, because, oopsie.
And
So with the applet, because you know how you can make it blue, and that depends on, like, that's the area it's covering.
yeah.
So would that be on the bottom 10%, right? Or
I'm trying to remember. I think so. The stuff that's to the left is what you're saying?
uh-huh.
Yeah, I think so. I think you still get the same thing though. Yeah.
Yeah, I think you're right.
But I think it just means like when you put your z-score, it's the negative. Z-score, so the negative 1.282.
Okay.
And then you just use that for the
Cool.
next one.
Okay. So it's negative 1.282. Cool. Then, what is the quantitative GRE score for a student who scores in the 10th percentile?
I didn't get that one.
How would we-
We're on D, right?
Or D?
That we're just talking about.
Mm-hmm.
Okay. The first time I did it, I used the positive with the z-score, and so I ended up getting it wrong because I checked the key. But just now I did it with the negative, and I got it right. So.
Okay, so how would you do that?
Yeah.
So you're just doing the opposite of when you do your z-score. So you have the your equation with the
Okay,
z,
yeah.
and you're just solving for x. So you do
Okay.
your z-score times your standard deviation, and then add your mean.
Okay.
So you take, for D, you take 1.282, the z-score, and you said
Take
you
the
multiply it by, oh, the negative?
because it's
Okay.
to the left of that. The negative 1.282.
282. And then you multiply it by the standard deviation?
So the 8.8.
Okay.
And then you add the mean.
And that's how you get the 10th percentile or whatever?
Yeah, because you're just solving for the x.
I'm trying to have the screen open and my I can do it at the same time.
I'm getting a bunch of dings on me. Is that somebody else's computer? I'm just wondering.
Getting a bunch of what?
I get like little, I don't know, I keep hearing like ding, ding. I
Oh
don't
yeah,
know.
I
I
hear
don't know.
that. Cool.
Is that me? Maybe.
Maybe. I don't know. I don't see anything on mine
Okay.
at the moment. Okay. Doesn't matter if it's not you guys right now.
So did you just know to use a certain formula to get the quantitative GRE score that you
um,
plug into, or is that just your intuitiveness that you knew that that's what you're supposed to do?
no, it said, I think it's under calculating percentiles in the
Okay.
textbook,
Uh-huh.
and I think it explains it in there.
Okay.
But the z-score formula is
Uh-huh.
the x minus the
Right.
mean divided by the standard
Right.
deviation, and it says that the percentile is you're just solving for that x. So
Okay.
and it says it in there, and I think it walks through one of them with you, so you can look at that and it'll show you.
Okay. Thank you. Cool.
Awesome.
Did we all get?
So are we?
Oh, go ahead.
I was just gonna ask the same thing.
Oh,
Did everyone get that?
the 139.5184.
Yeah, that's what I got.
Okay.
So, did you get that, Elena?
Yeah.
Yep.
Okay, perfect. So are we ready for number 7?
I think so.
Okay. All right. The mean speed of hydrogen at room temperature is 1,800 meters per second with a standard deviation of 600 meters per second. At room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of 180 meters per second. And a standard deviation of 600 meters per
Right.
second.
Just fill in the blanks.
And then B. What is the probability that a randomly selected particle has a speed over 2,500 meters per second? Huh?
Okay, so we're dealing with probability. So is this something we can plug in once we get the z-score into the applet?
Yeah, I think so, because that's just the same as like the percentile, because it's the percent. So it's
Right.
also the probability. At least
Okay, so we do.
how I understood it, and when I looked on them, it looked like I did everything right. So
Okay. So z equals x. What is that formula?
minus the mean.
Minus the mean over the standard deviation. Okay,
Yeah.
so what is our data? What is the mean again? Is it 8.8?
The 1800.
1800. Excuse me, I'm looking at the wrong thing. Okay, so 1800. The standard deviation is 600. And we put in 2500.
And I think I got 1.16.
That's what I got, yeah.
Okay. And then when we put it into the app, it's a speed over, right? So it's everything on the right.
So then did you get for the area 0.1216?
Just now I got 1.1230, but on my other one it says 0.128, 1218.
So back up, I'm sorry, what did you get for the z-score? That's what you were figuring out? What did you get for that?
1.16, and it's repeating.
I didn't get that. I got 3.86. So what am I doing wrong?
So did you, Victoria, did you put in in the z-score 1.16, and then because it always asks for
Yeah.
3 decimals, so
Oh.
just put a 0 at the. So I
Yeah.
wonder if we do 1.167 just to round that.
Yeah, okay.
So then,
Now I got the 1216.
okay, cool.
Okay.
Or 0.1216.
Repeating. Okay. And then you put that in the applet. Okay.
Did you figure it out, Mindy?
Yeah, I'm
Okay.
sorry if you don't see me at the moment. I'm trying to figure it out.
It's alright.
Okay, so you got 0.1230, you said, for the area?
The first time I did,
Is that right?
if you round the third digit to a 7, you get the 12, or 0.1216.
0.16, okay. Alrighty.
Alrighty. So did you get that, Elena?
Yeah.
Okay. Perfect. All right. So for C, it says, what is the probability that a randomly selected particle has a speed that is less than 2,500? So couldn't we just go back to that same applet and just...
I think highlight the other side.
Uh-huh.
Yeah.
Would we highlight
Because it's
just the very far part or the middle part and the left side?
I think it's everything to the left of the first of the z-score on the right. Does that make sense? To the positive one?
Yeah, so then what did you get for the area? Did you get 0.8784?
Yeah.
Okay. Yeah, me too. Cool. Do you guys understand why it was 4?
Say that again?
So for C, we got 0.8784.
I got 0.8770, so I might be off slightly. You're highlighting from the positive Z-score to the left of that? Is that what you're doing?
Mm-hmm.
Yes. Yes.
Okay.
So it's
And
using
it
the
could
same
just be
applet.
because your Z-score could just have one decimal, one number off, but that's pretty much this exact same thing. So.
But when you're doing 10 quiz questions, you don't have a room for error as you get a bad grade. So. Okay.
But so did you get that, Elena?
Yeah, I got that too.
Okay, cool. Alrighty. So D says, what is the probability that a randomly selected particle has a speed that is less than 100 or 1,500 meters per second? So we have to do.
Okay, I need help. Walk me through this one. Is it the same as the other one where we're doing the Z-score first?
Yep. Yeah, it is.
Okay.
But
So
instead we put 1,500 instead of 2,500.
Okay.
Yeah.
Got it.
so you get a negative Z-score, but you still just put that in.
Okay, so. All right. So a negative 0.5.
Mm-hmm.
Okay. So that's the Z-score.
Ooh, let me do this one. I'm worried.
Did we get 0.385?
Yes, I got that.
385. Okay.
Is it highlighted from the positive Z-score to the left? Does that matter?
Yeah, it needs to be to the left because it's less than.
Okay. That does change the area, doesn't it?
Yes, it does.
Okay.
Mine was still 0.3085.
3085? Okay.
Mm-hmm.
Okay.
And
And then what is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? I remember reading about that, but how do we do that?
I think, oh, what did I do? I think you find the Z-score, or we have used the Z-score of each one. Oh, let me check something real quick.
Okay. Let's see if I can find that.
I think.
Are you okay?
Yeah, we're okay.
Okay.
That
Sound
was
like
just
someone's
my
coughing.
cough. Yeah, that was my wife coughing up her lung.
Ah, okay.
But she's okay.
Okay.
All right. Are you finding where it says randomly selecting? I'm looking through the text.
Alright. I think what I was thinking,
Oh.
and I was just checking it because
Mhm.
I think it shows it on there, but I'm not sure. Because you're doing it between, you're taking, so it has to be
Ah.
less than the 2500
Okay.
probability, and
Mhm.
it's got to be more than the 1500. And so you just use the probability of the less than from C, and because that's going to include your middle in that other part, so you subtract the 1500, the less than 1500 part. Does that make sense? It's kind of a visual thing in my head.
Is it the idea of doing in between probabilities? That idea or no?
Um,
I'm a visual person. I have to see
yeah.
it.
If you go to the applet,
Okay.
so if you highlight that middle section and the
Uh-huh.
section to the left or whatever, kitty, get off me. Sorry. And so that's when you're on C, it says less than the 2500. We know that that's a positive z-score. So that's going to be your middle and your left section there. And when you do your 1500, you're taking away that part on the far left.
Okay.
So so that's everything that's less than the 1500, which is what D is. And so you're just subtracting C from D. Does that help at all? I feel like it's not very easy to explain on.
I'll be honest, it's clear as mud to me. Okay.
Okay.
Okay. Let's see. What's probably a random selection part about this p that is less than 1500? Are we on D still, right?
We're on
E.
Oh, we're on E. Okay. Whoops.
Yeah. I wish I knew how to explain it better.
Did you have an aha moment?
Yeah, kinda. Okay. So if you go, how do I explain it? Yeah.
Difficult.
Okay. So in the previous questions, we were finding a random particle that was above 2500, or above 2500 and below 100 or below 1500. But now we're trying to find it in between them. And so we're not going to be using the numbers from the previous question, because that's what I did, and I got it completely wrong. So so we have to find. We kind of have to go through all the steps again.
Okay.
But so we have to find the probability of. We're trying to find it in 1500. So we have to first find the probability of a random particle that's moving under 2,500 meters per second, and then so let's just find that real quick, and then we'll move to the next part.
That's 2,500?
Yeah, so we have to find kind of what we've done in the previous
Did we
one.
find that in B?
That's C.
And we found one that was moving fast. Did we find one that was moving slower than 1,500?
Yeah, I think C is what is the probability that a randomly selected particle
Oh yeah.
has a speed that is less than
Oh, okay.
2,500?
Cool. So yeah, we did.
Yeah, and then
So that's 783.
yeah.
And then now we have to find it if it's moving faster than 1,500, because we're trying to find in between those two.
So we subtracted from negative 0.5 because that was the one that was 1,500.
I think you just subtract 0.385 because you're on D we used the negative z-score.
Yeah.
So
Okay.
your 2,500 is everything this way, and your 1,500 is from here this way, and so you're subtracting that so that you just have right here.
So E should be set up 0.873 minus 0.3085? No?
Yeah.
Yeah.
Okay. Thank you.
So that's probability. So then, Victoria, did you get 0.5698?
Yeah.
Okay. Cool. Got it. That makes sense. Is that making sense for you, Elena?
Yeah.
Okay. Perfect. Alright. And then for Mindy, did that make sense for you?
Well, I got 0.5645, so I'm off somewhere in my decimal points or something.
What was?
Did you get 0.8783 minus
0.8783? Okay.
Yeah.
Okay. That's what I'm doing wrong.
Oh, okay.
Okay, now I got it. 0.9698. Thank you. All right.
All right. Last question for this, and then we can do the quiz.
We don't have another page? I thought we had another page.
Yeah, it just takes up, just because it's a lot of space, but it's just one question. So
Oh, okay.
I think it says, what is the third quartile of speeds of hydrogen at room temperature? During your group preparation meeting, you will determine whether the data represented in these QQ plots are normally distributed or not. Record your answers for each graph. Justify your answer.
I think those are two separate questions.
Hmm?
I think those are two separate questions.
Really?
So F still goes with the other one. So what's
I
the
agree.
quartile? I think if you check
It's
the
still part of 7.
Oh yeah, that's weird. Oh, gotcha. Okay, there just wasn't a space. Okay, I see it now. Gotcha. So what is the third quartile of the speeds of hydrogen at room temperature? Oh, okay, I see.
I'm trying to remember how I did this one. I really should write down when I do these. Like, it would make life so
Yeah,
much
you can
easier.
share your brilliant brain trust there with us, Victoria.
Might not be saying that later in the semester.
Well, you're already impressing me. Okay.
Thanks. So,
Okay, so the third percentile is just 75%
Right.
of
right.
the applet. So
I just
so the third quartile of speeds of hydrogen at room temperature. So
So-
wouldn't we just put in the
0.75 into the area.
Yeah.
Oh yeah, that sounds right.
So that's the 75th percentile. So okay. And then I got 1.150 on my z-score.
Okay, so what part is highlighted when you do that? Just the very right?
It should be the middle and the very left because it's the
Okay.
Oh, let me try that again then. I don't think I had it highlighted right. Okay, there we go. 0.674 is what I got.
okay,
That's what
yeah.
I have.
That's what I got too.
Sorry.
Cool.
Alright, so then we just solve for x.
Okay. With
So
the z-score formula?
Yeah, so the
Okay.
0.674 times 600,
Okay.
etc. Okay, yeah.
Mm.
Did you just say 0.674 times 600?
Uh-huh.
Okay. So
Because you
you're not.
already have your z, so you're kind of going backwards.
You're right. I was gonna say that's okay.
So you do 0.674 times 600 plus 1800.
So z is 0.674. No, that's wrong. Yeah, that's
Z is 0.674,
okay. I'm right. Okay.
and then your x, or what it's asking for, the
Mhm.
speeds or whatever, is the 22.04.4.
22.
That's what I got.
Okay, I'm gonna have to ask one more time. So 0.674, that's the z, is equal to 22.04. How did you get that?
So 0.674 times
Okay.
600.
Oh, okay.
And I got the 404.4, and then plus 1800.
Okay. Sounds having fun over there, huh? Okay. So your final answer, Victoria, was again 2204.4. Is that what you got, or is that wrong?
Nope, that's right.
That's right. Okay.
Yep. Are we all good then?
Yeah.
Ready to move to the last one?
Yep, I'm ready for that too. Right. So, determine whether the data represented in the QQ plots are normally distributed or not. Record your answer for each graph. Justify your answer. So, don't the QQ plots? That's kind of if you put like a just a line in the graph. That if it's along the line, if all the dots are pretty much along that line,
Smooth,
then
yeah. Mhm.
it's normally distributed, right?
Yeah. So we can just look at them and be like, normal, non-normal.
So A, I would say not normal
Yeah.
because it's not. And then B, not normal, right?
Yeah, it's in a S shape. So
Yeah.
that's whatever I wrote down. Skewed left. Yeah.
Okay. And then C, that's kind of, I don't know if you can
When I looked it up,
call that normal.
when I looked it up, it was normal. And I
It was
think
normal?
it's because it technically does go along a line. It doesn't. The curves are broken up.
Okay. Okay.
C is considered normal?
Mhm. Because it's not like it's one big curve or it's not one big curve. It's like a little curve
C,
up and kind of
yeah.
follows along a line.
Yeah. Yeah, that makes sense. And then D, that's normal, right?
Yeah, D is normal.
And then E, would that one be not normal because you said it kind of, because right in the middle of that one, all of them tend to go up and then come back down?
Yeah, I think E is not normal because it kind of goes up and then curves away. So
Uh-huh.
yeah, it's not.
And then
But then
F would be,
F is normal.
cool.
Is E considered normal or no?
No.
No.
Too curvy.
Yeah.
Right.
Well, I think it's because there's a lot of plot points on that first part, and then
Okay.
the most part of it kind of stays. It starts curving there.
Okay.
But I think if you go to the answer key, it says
Cool.
Y too. If you want to look there.
Are we allowed to use notes for our quiz? I forget. Our group quiz.
I haven't seen anything that says we're not allowed to or that we are allowed to, so I don't know.
Okay. Because I feel like I would need notes more on this one. So.
I think with our four brains, we could probably figure it out. Because there's really only one equation that we needed to know, which is Z
That's the z-square.
equals X minus the
Mean divided by the standard deviation.
Yeah. So, and I think that was really the only
Okay.
equation we needed to memorize, so I think we should be good.
I think after going through it, I went ahead and did the homework part too. So After doing it, I think I remember more of it just from practice. So
Awesome.
between the four of us, like you're saying, I think we'll be okay.
Yeah. Alrighty. Well, are you guys ready to take the quiz?
Yeah.
Sure. Okay.
Yeah.
Let's start. I completed the individual.
Okay, let me get in there.
Alrighty. So number 3 says the total area under a density curve must equal. Do you have any idea about that one?
That'd be 1.
Yeah.
1? Oh, that makes sense. Okay. Yeah.
Are you in the quiz already?
Yeah.
Oh, okay. I have to log back in and kick me out, so I'm trying to get there.
Oh, okay. We'll wait.
Not saying I can add much, but I definitely want to be part of it. Okay.
Alrighty.
All right. Let me try to get both screens up here. Come on. All right, trying to make them both appear. Okay, so you said the total area under a density curve must equal 1. That's one of the rules of a density curve, so I agree with that.
Yeah.
And number 4, under certain circumstances, a density curve can drop below the x-axis.
That's false.
Yeah.
That's what I put.
That's false.
Alright. And number 5, a normal density curve is symmetric.
True.
Right.
Let's be
True.
bell-shaped.
Yeah, I think it's true.
Bell-shaped curve. It's symmetric.
Alright, which of the following elements of the figure represents the z-score in the image? C.
C.
Which of the following elements of the figure represents the probability that the random variable z on?
Which of the
Greater
following
than 1?
elements figure represents the probability the random variable z will be greater than?
Wouldn't that be B?
Yeah.
Because that'd be, if it's greater than 1, then it would be to the right of that
Right. Yeah.
line.
That's what I put.
So for 7, it's B.
Mm-hmm.
B. Yeah. Alrighty. Then 8. According to the 68, 95, 99.7% rule, what proportion of the data from a bell-shaped distribution will be within one standard deviation of the mean?
68.
68%.
Isn't it 68%?
Yes. 68, yeah.
Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. If the answer is that, you would enter that. Okay.
So,
Okay.
so we're using the applet and just putting in 1,
That's what I was going to do.
0.1, and then it's everything in between, and that's the area. Sometimes the way they word the questions start to confuse me.
Yeah.
So where do we oops, there we go. So where do we put 1?
In the Z-score?
Yeah, that's one. I read that.
Oh, okay. I put it in the wrong place.
Is the whole thing shaded or no?
Just between -1 and 1.
Okay.
Yeah, what portion of the values from this random variable will be between -1 and 1? So that's,
You get 0.6827.
That's what I got.
yep.
But then it says to round to 3 decimals. So 0.683.
Yeah.
.683, right?
Yeah.
That's what I put. Okay. Number 10. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable between -2 and 2?
That's
So
like the same thing.
just the exact thing. Um,
Oh, okay, so you're doing the same thing but with 3. Okay.
oh, so for number 10, did you get 0.955?
Let me look at it one more time. Yeah, 9545. 0.955.
We're going to do it to 3 decimal places, so 0.955.
Yeah.
Okay.
.995?
955.
.955.
Yeah.
Yeah,
This is funny. So the number 11, did you get 99.997?
that's what I got. You
yeah.
got .955?
For number
That was
10,
for 10.
for number 10 is 0.955,
Oh, I missed.
and then
Okay.
number 11 is 0.97.
Okay, I missed.
That's funny. If you look at 9, 10, and 11, that's the 68, 95, 99.7 rule. That's funny. Okay. Oh, and then that's number 12.
Oh, yeah.
Look carefully.
Way to go.
I did it before you and observed the questions. Awesome.
Okay.
Okay, I'm on 12 now. You are past that, or where are you at?
Yeah. So number 12, it just says look carefully at the last 3 answers.
Oh, okay.
And what?
Yeah. It's the values that match 68, 95, 99. Okay. Right?
Yep.
Yeah.
Okay.
Cool. All right. Now for the math stuff.
Okay.
All right. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally in the United States. The protein requirements is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population means protein requirements for adults is 0.668 or 0.66 grams, and the population standard deviation is 0.07 grams. Use this information to answer questions 14 to 17. Okay. Okay, so then.
So,
Alright, so what proportion of the population has a protein requirement that is less than 0.6? So, for this one, wouldn't we just do what proportion of the population?
We do the z-score because it's giving us the mean and it's giving us the standard deviation. Is that what we're figuring out?
yeah, that's
That's
what
how I read that.
yeah, that's what I was just doing.
Okay.
I got the z-score, and then
Okay.
I put it into the applet.
In the applet? Okay, I'm going to try that.
And then it's less than the z-score, so I got, well, I'll wait till you guys get it before I
Okay.
just send it.
Alright.
Did you get a negative number?
For the z-score?
Yeah.
Yeah.
Okay.
So when you put that in your
Uh-huh.
applet, and it's everything less, you're going to do it less than the negative z-score.
Okay. So did you get negative 0.857 for the z-score?
Yeah.
Okay.
And then I just put that into the applet.
Uh-huh.
Shade to the left of the negative 0.857.
Okay, did that.
And the area is, that's your number.
0.1957, but it should be 0.196.
Yep.
Okay.
That's right. And then for 14 for greater, did you get for the next one, did you get 0.804?
Yep.
That's what I would get. Yeah, cool. Right. Proportion of population, 114 is less than 7.
Okay, so now you're going to, it says more than, so it's positive, and you're going to be
so
on
it's
the
just,
other side, right?
yep, just on the other side of it.
Okay.
And so that's where we got 0.804. Is that what yours gives you?
I'm not there yet, but I'll let you know.
Okay.
do you have to do calculations again in 14, or are you just using the positive of the answer from 13?
You're just using the greater than.
Greater than.
So just, yeah, like you said, just on the right of that.
I'm doing something wrong. Okay.
Are you shading the middle and the one
No,
on
I'm
the
not.
far right?
Oh, okay. That's what I'm doing wrong incorrectly. Okay. So, all right. So that's 0.8043, you said? So,
So just 0.804.
yeah, 0.804.
Yeah. Because if it's greater than, you're using that same z-score. So
Okay.
that's what you include everything on that side.
Thank you.
Look what I bought for you. Thank you. How was it?
Two more questions. I said there's just two more questions, right? 15 and 16.
Yep.
Okay. So it's the same idea, less than, oh, maybe not. Okay. All right.
It's like the same thing as 13, but with 0.7.
Right, 0.70. Okay.
And on that one, you get a positive z-score. So you shade everything to the left of the positive z-score.
Okay. So I'm on 15. So for the z-score, did you put in 0.57?
I just erased it on my thing.
Oh.
Sorry. Let me do it real quick. Yeah. 0.571.
Right.
Yep.
Okay. And then you said everything from the negative of the right of that?
On the left of it.
The left of it. Oh, okay, because less than you said. Yeah, that's right.
Yeah.
So the area is 0.284?
I got 0.716.
Okay.
So you put 0.517 in z-score.
Are you supposed to shade in the middle and the left? Is that right?
Yeah.
Okay, that's why.
Okay.
So 0.772, you said? Or 716? 716, yeah. To the third decimal, that's right. Okay.
So you guys are doing 15, right?
Yeah. I just did 16 too.
What did you get for 16?
0.52.
Okay. For 15, what did you get?
For 16?
For 15?
For 15, 0.716.
I did that wrong.
Did you get 0.571?
Yeah, so I must have just put it in wrong. 0.571. 7, 1. And we're trying to find less than that. Oh, then it's positive. Okay, that's what I did wrong. Yeah. So that is 0.716.
Yep.
So then this. So then when we just subtract for number 16, we do 0.804 minus 0.716.
No, I think you're doing because it's between 0.6 and 0.7. You're doing the ones that are less than. So you're doing the
yeah. So we do
0.716 minus 0.196.
Gotcha.
Does that make sense?
Uh-huh. Because
Okay.
So you're for 16, you're not taking the answer from 14 and 15 and subtracting it. Is that incorrect?
Yeah, that's not. You're taking 15 minus 13.
15 minus 13. Okay.
Because you're looking at the ones that are less than.
Okay.
You're 70 and you've got your 60, and then you take off the 60, so you just have in between. I don't even know if you can see my hands, but I'm trying to like visualize it for you. I'm part Italian. I speak with my hands.
Okay. So 0.196 minus 0.716 is what you're saying?
0.716 minus 0.196.
Okay.
It has to be a positive number.
Right. That's right. I did see that in the note.
So wouldn't we find, because we're trying to find it greater than 0.6? In between
Yeah.
and 0.7?
But 0.7 includes everything on the left. And then your 0.6, the part that's less than, will take out that part that's to the left of that. So you'll just have what's left between those two. I don't know if that makes sense. It's kind of, because I kind of want to like color a picture for you and show you, but I can't.
Yeah. I'm just trying to visualize it.
Yeah.
But I think, yeah. Okay.
Guys, shade the left of each Z-score you calculate and subtract the smaller.
So did you get 0.52?
Yeah.
0.52, that's what I got. Is that what you said?
Yep.
Yeah.
0.520. Just as you have to do.
Oh, yeah, that's probably a good idea. Okay. Is that it then? Should we submit?
Do you want to go over the answers one more time? Just make sure we're all... No?
Sure.
I don't care either way. I feel like we did this right. But
well, the very first quiz, Walker and I were doing it together, and he got perfect score and I missed one because the question was phrased differently. But I think they're all the same this time. So I'm just concerned about that. But we kind of all read them the same way, so I think they're all the same.
Yeah.
Because he asked me, well, why did you get a different score than me? I'm like, I don't know. And oh, that's why. It was phrased differently than like the multiple choice question.
Yeah.
Different. So.
You know the one with the picture? Maybe we'll just check that one.
Okay.
Number 6.
Yeah.
Like, does your C point at the little squares on the bottom?
Does my C what? I'm sorry. Point at the little squares.
Yeah, the ones that say 1 in them.
Yes.
The
Yes.
z-score.
The Z-score. That's correct on yours too.
Mm-hmm. And then
Okay.
the B is the blank space on the bell curve.
Yes. So the answer for 6 is C, right?
Uh-huh. And 7 is B. So I
7 is
think we're okay there.
okay. All right.
That would be the only one I would think that
Yeah.
might be different like that.
Okay. Just wanted to make sure since.
Yeah, no, I understand. Okay. Should we
Are you
submit
ready?
then? Right. Seal our doom. Woo! Did you guys get your
100.
scores? 100.
Good job.
Yay! Thank you, team.
Did I do a virtual high five again? Where's my screen?
Good job.
Ooh.
Alrighty, sounds good. Well, I will see everyone on Tuesday then.
Okay. Is it going to be a standard 8 o'clock or 9 o'clock for you guys? 8 o'clock for me. It's
Yeah.
not going to be it? Okay.
Okay.
Alrighty. Thank you so much.
You're welcome. See you then.
We'll see ya.